Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hari ini kita akan tengok chapter 4, okay, improper integral. Okay, so for table of content, okay, we have two parts. Okay, so the first part is L'Hopital rule, and the second part is how to solve improper integral. Okay, so L'Hopital rule is the rules that we need to use to solve improper integral. Okay, so we have two categories, which is 0 over 0 and infinity over infinity. Okay, so for improper integral, we have two types. Okay, so type 1 and type 2. Okay, we look at what is the meaning of the L'Hopital rule first. Okay, what is L'Hopital rule? Okay, so if we deal with limit and the limit that we perform obtain 0 over 0 or infinity over infinity. Okay, so we need to use L'Hopital rule. Okay, so this is the limit. Okay, so let's say we have the numerator and the denominator, and we have the limit, the x tends to a. Right, what happens if both the numerator and denominator are finite at a? Okay, and we have the value of GA is not equal to 0. Then what we need to do is we just substitute the value of A for the limit. Let's say in this case, the limit x tends to A, and we have fx over gx. Therefore, what we need to do is replace the value of A in the functions. Okay, so replace all x with A, and for the denominator also replace all x with A. This is how we deal with the limit. Look at this example, example 1. Okay, so we want to look at how we want to solve the limit. Okay, solve the following limit. Okay, so limit x tends to 3, where we have x squared plus 1 over x plus 2. So as the previous slide, we need to substitute the value of a. So let's say in this case a is equal to 3. So we need to substitute into this fx and also gx. Okay, so we need to replace this x with 3. Okay, so this is the solution. Okay, so we just replace the value of x with 3. So we will obtain 3 squared plus 1. And for the gx, we obtain 3 plus 2. Okay, so the total will be the 10 over 5, which is equal to 2. Right, that's how we solve the finite limit. Okay, when x tends to a, we just replace the value of a in the fx and also the gx. Okay, but what happens if both the numerator and denominator tends to 0? Okay, so for example, let's say here our limit x is tends to 0, so our a is 0. Okay, and we have the function of fx, which is x squared, and our gx is sine x. Okay, so we basically just need to substitute our a here. All right, so a squared will be 0, and sine 0 also will be 0. Okay, so this is our answer, 0 over 0. But in mathematics, we cannot define any value, okay, for 0 over 0. So here we need to implement L'Hopital rule. Okay, it is not clear what the limit is because we don't know what is the value for 0 over 0. Okay, so in fact, depending on what function of fx and gx. Okay, so if we did not obtain the 0 over 0, we can have a normal value of limit. Okay, so this is L'Hopital rule for 0 over 0. Okay, suppose the limit of fx and the limit of gx is equal to 0 as a previous example. Alright, so what we need to do is we use these rules. We have the limit of fx over gx, then we need to transform this limit into the f prime x over g prime x. Okay, so meaning that we need to find the differentiation of the fx and gx. This is the case where we obtain the limit of fx and the limit of gx equal to 0. Okay, so the second rule is if the function of the limit, the differentiation of f and g as it tends to infinity or minus infinity, then same as the original function fx over gx. Okay, now we look at the second example. We have the limit x tends to 0, and we have the function of fx is equal to sine x, and the function of gx is equal to x. Okay, so how we want to answer? Okay, so in this case, if we substitute as usual the value of a equal to 0, okay, so we'll obtain the sine 0 over 0. So basically we will have 0 over 0. Okay, so in this case we cannot determine the value because it is 0 over 0. Therefore, we need to imply L'Hopital rule. What is L'Hopital rule? Recall back. Okay, so if we have this limit and it is equal to 0 over 0, we need to find the differentiation of the fx and also the gx. Okay, here. Alright, since it is 0 over 0, so we straight away convert to find the f prime x and also the g prime x. Okay, so the differentiation of sine x is equal to cos x. Differentiation of x is equal to 1. Okay, so after differentiation, we need to substitute the limit of a. So we just put it cos 0. We just substitute into the x. Okay, and 1 here. Okay, remain the same thing because we don't have any x value for the gx. Okay, so it will be equal to 1 over 1, which is equal to 1. Okay, so the limit for sine x over x when x tends to 0 is equal to 1. Okay, let's look at the next example. Okay, now we have the limit x tends to 1, which is the function for the fx is 2 ln x, and the function for the gx is x minus 1. Okay, so in this case, if we substitute the value of, okay, so here is typo, when the limit x tends to 1 here, so we just substitute the value of x with 2 ln 1 and x here with 1 also, so it will become 1 minus 1. So if we use our calculator, 2 ln 1, okay, so we have 2 ln 1, so we have 0, and 1 minus 1 also will be 0. So in this case, we cannot determine the exact value, 0 over 0. Therefore, we need to use L'Hopital rule, which is we need to find the differentiation of f and also the differentiation of g. Okay, so 2 ln x, we need to differentiate. Okay, so ln x, just refer to the formula table. Okay, so the differentiation of ln x is 1 over x. Okay, differentiation of x minus 1 is 1. Okay, alright. So after the differentiation, you just substitute the limit. Okay, the limit here is 1, so 1 over 1. Okay, multiply with these 2. So we have 2 over 1, which is 2. Okay, what happened if in the second attempt here, we still got 0 over 0? What we need to do is we need to differentiate it again, the function of the fx and the gx. Okay, until we obtain value other than 0 over 0. Okay, let's try example 4. Okay, so we have the limit x tends to 0 and the function of fx is ex minus 1 over x squared. Okay, let's try this. Okay, so if we substitute the 0, so exponent 0 minus 1, okay, over 0 squared, isn't it? So for the E naught, okay, so just use a calculator. E naught is equal to 1. Okay, so 1 minus 1 is basically 0. Okay, so it will be 0 for the fx here. So for the x squared here is 0 over 0 squared, so also 0. So we will obtain E naught minus 1 is 0 and 0 squared is 0. So for this condition again, we need to use L'Hopital rule, which is we need to differentiate the fx and also differentiate the gx. Okay, since that, okay, for the ex minus 1, we need to differentiate. So we will get the ex back. Okay, just look at the list of formula. The differentiation of ex is ex. And 1, of course, will be 0 because it is a constant. Okay, so for the x squared, the differentiation of x squared is 2x. Okay, so now we just substitute the limit 0. Okay, and 2 multiply with 0 for the x here. Okay, so E naught, again, E naught is 1 and 2 multiply with 0 is 0. Okay, so 1 over 0 is basically undefined. So we have this value. We just remain with undefined. We don't have to use L'Hopital rule since L'Hopital rule only cater the problem of 0 over 0. Okay, so 1 over 0 is undefined. Okay, next example. Okay, example 5. Okay, so we have the limit of x tends to 0 and the function of fx is 1 minus cos x. Okay, so the function of gx is x squared. Okay, so if we substitute the 0 here, okay, and use your calculator, 1 minus cos 0, we will obtain 0. Okay, for the fx. Okay, how about for the gx? 0 squared also 0. So we will obtain 0 over 0. In this case, we need to implement L'Hopital rule. Okay, since we have 0 over 0, we just substitute 1 minus 0 over 0 squared. We will obtain 0 over 0. And we need to use L'Hopital rule. Again, what is L'Hopital rule? We need to find the differentiation of fx, okay, which is f prime x, and also the differentiation of gx, which is g prime x. Okay, alright. So 1 minus cos x, we will have sin x for the differentiation, and the x squared also we will have 2x. Okay, then we just substitute the limit, which is x tends to 0. Just substitute 0, sin 0 and 2 multiply with 0. And again, in this case, we obtain 0 over 0. What we need to do? We need to use L'Hopital rule again. Alright, this is the second time for the same patient. Okay, so we just differentiate the sin x. Okay, just look at the differentiation table. We will get the cos x, and we need to differentiate it again to x. We will obtain 2. Okay, so in this case, we say again we just substitute the limit. Okay, 0. So we obtain cos 0 over 2. Okay, so cos 0, if you use calculator, cos 0 is equal to 1. Okay, so the answer will be 1 over 2. Okay, so the limit for 1 minus cos x over x squared when x tends to 0 is 1 over 2. Alright.